Welcome to my 54th tutoring session in A-level chemistry. In this video, I'll talk about the waveform of light, the diffraction and interference pattern brought about by the waveform of light as it passes through an obstacle, which could be a narrow aperture or a slit. Kindly subscribe my channel, share, like, comment, and watch the full video. The electromagnetic radiation is a form of radiant energy. The light exhibits both wave characteristics as well as particle characteristics. Now the waveform of light can be visualized as a sinusoidal wave, and the sinusoidal wave can be described with parameters like wavelength and frequency. Wavelength and frequency are the important wave descriptors. Light also exhibits particle characteristics with packets of energy called quanta or photons. Here are some of the important wave properties of light, which includes reflection, refraction, interference, and diffraction. The incident light bounces off a surface due to reflection, and the incident light is getting refracted, and during refraction you see bending of light as the light travels from the rarer medium to the denser medium. Another important wave property of light is interference. When two waves combine or overlap, it results in either constructive interference or destructive interference. During constructive interference, the crests and troughs of the two waves, they align in phase, while in case of destructive interference, the two waves align out of phase. And the most important wave property of light is diffraction. Now, what you observe during diffraction is the bending or splitting of waves when the light passes through an obstacle like a narrow aperture or slit. That's about the wave nature of light. Now what about the particle nature of light? Now the particle nature of light can be explained by the photoelectric effect. During the photoelectric effect, the photon or the light impinges or strikes the metal surface, and an outcome is ejection or emission of electrons from the metal surface. Now the photoelectric effect that causes the emission or ejection of electrons from the metal surface can be explained only by the particle nature of light or electromagnetic radiation. Now diffraction is nothing but bending of waves. A single slit produces a diffraction pattern. So as the light passes through an obstacle like a narrow aperture or a slit, you see bending of waves or spreading of waves coming out of the slit, and what you see on the screen is the diffraction pattern. So diffraction refers to the bending or spreading of waves as they pass through an obstacle or a narrow slit. So what you observe during the single slit experiment, after passing through the slit, the wave spreads out or bends, and a diffraction pattern is observed on the screen. And this is characterized by A central bright, most intense fringe at the center with alternating dark and bright regions on either side with decreasing intensity. So light diffraction all directions through a single slit, and depending on the angle sin theta with respect to the beam's initial direction, interference can be either constructive or destructive. And what you observe during the double slit experiment, a wave passes through two narrow closely spaced slits acting as two coherent sources of waves. The wave spreads out from each slits and overlaps. And an interference pattern is observed on the screen consisting of alternating bright fringes caused due to constructive interference and dark fringes caused due to destructive interference. So what do you learn from the single slit and the double slit experiment? The single slit experiment demonstrates the diffraction, the bending of waves, while the double slit experiment highlights the interference pattern or the overlapping of waves. So both phenomena, that is diffraction as well as interference, are successfully explained by the wave nature of light, and these apply to other types of waves. So that's about the diffraction. What about the interference? Now interference can be explained by the double slit experiment. A double slit produces an interference pattern where the waves from the two slits interfere either constructively or destructively. Let's see how the waves from the two slits interfere, resulting in constructive interference as well as destructive interference. So light passing through a double slit, you see wave 1 emerging out of the first slit and wave 2 emerging out of the second slit. Remember, both waves 1 and wave 2, they emerge simultaneously from the slits. And what you see on the screen is dark spot and bright spot. Ci stands for constructive interference and Di stands for destructive interference. Now bright spot on the screen is due to constructive interference, while the dark spot what you see on the screen is due to destructive interference. Why do you see bright spot during constructive interference and dark spot due to destructive interference? Let's find out. Now during constructive interference, the two waves combine or overlap, and the outcome is a resultant wave with an increased amplitude, and this is caused due to constructive interference. And during constructive interference, the amplitudes of the individual waves, they add up, creating bright fringes. And most importantly, during constructive interference, the waves must be in phase. That is, their crests and troughs must align. So a double slit experiment produces an interference pattern, and the emerging waves from the two slits interfere either constructively or destructively. During constructive interference, the amplitudes add, creating bright fringes, while during destructive interference, amplitudes cancel, creating dark fringes. So that is about the constructive interference. Now what about the destructive interference? Now during destructive interference, Light passing through the slits, they emerge. And what you see on the screen is dark spot and bright spot. So you understood the reason for the bright spot on the screen. So the bright spot on the screen is caused due to constructive interference, and that happens when the two waves merge in phase. And what happens during destructive interference? And why do you get the dark spot during destructive interference? Let's find out. Now, during destructive interference, when the two waves combine, overlap, or merge, the resultant wave has a zero amplitude, and this is due to destructive interference. Now, why do you get a zero amplitude during destructive interference? The reason being, the value of the two waves mutually cancel each other. The value of the first wave, that is +1, and the value of the second wave, that is -1. When you add up, you end up with 0. So this leads to mutual cancellation. So during destructive interference, the waves combine to produce a wave with 0 amplitude or reduced amplitude. And most importantly, the waves must be out of phase, meaning the crest of one wave aligns with the trough of other, and the amplitudes partially or completely cancel out. So bright spot on the screen is due to constructive interference, while the dark spot on the screen is due to destructive interference. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.